Hey guys, in this video we're going to be doing some mixed review of math topics that show up on standardized tests like the ACT, SAT, and MCA. A lot of these are skills that you have learned in this class or in previous classes, but it might be a while since you've practiced them, so that's what we're going to do today. The first one here says, a geologist measures the widths of 4 microscopic crystals. Which of these widths listed below is the largest? So I noticed that of the 4 options, they're all in scientific notation. So I have some number multiplied by 10 to a power, times 10 to the negative third power, and times 10 to the negative second power. Okay, we know from our unit on exponentials that a negative exponent can be written as a positive exponent if we rewrite it as 1 divided by that term. Okay, so 10 to the negative second power is 1 divided by 10 squared. 10 to the negative third power is 1 divided by 10 cubed. So I'm either dividing by 10 squared, which is 100, or 10 cubed, which is 1,000. Okay, if I want the biggest value, I know that I don't want 10 to the negative third power. That's much smaller than 10 to the negative second power. So I'm going to eliminate A and I'm going to eliminate B because I know that those are smaller. Okay. C and D are both times 10 to the negative second power, and I want the bigger value, so 5.74 versus 5.18. 5.74 is going to be the bigger option. Looking at number 2, we have a geometry problem. It said that Rosa has purchased a larger van for her business. She intends to use a similar, larger logo sign on the new van. We want to know, what will the length L of the new logo sign be? So looking at the smaller triangle logo, our dimensions are 3 feet by 4 feet. And on the new logo, we have this dimension here, which is the hypotenuse of the triangle, 7.5 feet or 7.5 feet. And I want to know what's the length of the bottom of that logo, L. Okay, so since these are similar figures, I know that I can use ratios to help me out. But I need to compare the same side lengths. So I need to figure out what's the hypotenuse of that smaller triangle. Okay. From geometry, I know that the Pythagorean theorem relates the 3 sides of a triangle. A squared plus b squared is equal to c squared. And I'm solving for c, the hypotenuse. So I'm going to plug in the numbers that I know. 3 squared plus 4 squared is going to give me c squared. And then I'm going to simplify to solve for c. So 3 squared is 9, 4 squared is 16, 9 plus 16 gives me 25. 25 is equal to c squared. If I take the square root of both sides, I find that side c is 5. Now normally we would consider both the positive and the negative when we take the square root, but since we're talking about side lengths of a triangle, we only have a positive side length, so that hypotenuse is going to be 5. So I'm going to set up a proportion to relate these 2 triangles, right? And I have these sides for the hypotenuse 5 and 7.5. So my ratio here, going from the smaller to the bigger triangle, is 5 over 7.5. Now that ratio must be consistent among all the other sides. So I'm going to relate 4 and L, because L is the side that I'm looking for. So I'm going to go in the same direction, smaller to bigger. So I'd have 4 over L. And now I'm going to use cross multiplication to solve this proportion. So I'm going to multiply 4 times 7.5 and set that equal to 5 times L. Okay, with a calculator, I'm going to do 4 times 7.5. That's going to give me 30. So 30 is equal to 5 times L, and then I'm going to divide both sides by 5, and I get that L is equal to 6. So that's option C. Next up is another geometry problem. It says that William draws a picture of his yard to help figure the area of his yard. He needs to know how much grass seed and fertilizer to buy. The shaded area represents his house. How many square feet of yard does he have? So I want to know the non-shaded area. So I want to figure out the area of the lawn, so the area around his house. So I need to take the area of the big rectangle, the whole, and then subtract the area of his house to find the area of just the lawn. Okay, I know that the area formula for both is going to be base times height, because that's the area of a rectangle. Okay, so first I'm going to start with the big rectangle. Okay, and I'm going to take 100 times 150. That gives me 15,000. And this would be square feet. The area of this smaller rectangle, which is his house, has dimensions of 40 by 60. Okay, and that's the value that I'm subtracting. So I'm going to take 40 times 60. That gives me 2,400. And then I'm going to subtract 15,000 minus 2,400. That's going to give me the area of the yard, which is 12,600 square feet. So that's option B. Number 4 here is a probability scenario. It says that Casey, our pet iguana, whacked his tail into a pile of marbles. One of the marbles went under the couch, never to be seen again. There were 6 red marbles, 11 orange marbles, 4 blue marbles, and 7 multicolored marbles. What is the probability that one missing is not orange? So with probability, we're going to set up a ratio. And in that ratio, the numerator is going to be what we want to happen or what we're interested in happening. And the denominator is going to be the total number of possibilities. So I'm going to figure out what is the total number of possibilities. We have 6 red, 11 orange, 4 blue, and 7 multicolored. If I add those up, the total number of possible marbles to have been lost is going to be 28. So again, that's the denominator. Okay, now what I want is for this marble to not be orange. So what I want to happen is the total of all of the marbles that are not orange. So I'm going to add up 6 plus 4 plus 7. That's going to give me 17. So 17 out of 28 is the probability, option C. Next up is a graph analysis question. So here we have a bar graph, and it says the chart below shows the average size of a U.S. farm in acres from 1940 to 1955. If the trend in farm size continues, which of the following is a logical conclusion? So I'm going to try to eliminate ones that I don't think are logical conclusions. Okay. So A says larger farms will mean less food will be produced. Well, I don't really have anything about how much food is going to be produced. I just have the size of the average farm. So I don't know the food production. So I can't say that that's going to be a logical conclusion. I don't know anything about the production. More farms will produce more food. Maybe, but I don't know anything about the production. So I'm going to come back to that, but I'm skeptical. C, the average size of a farm will increase in the future. That seems logical because if I look at the trend, right, it's going up. The sizes are getting bigger. So that one feels like a definite possible conclusion. And D said there will be more farms in the future. Well, I don't know how many farms there are. I just know the average size. So I can't make any conclusions about how many farms there are. And although B feels logical from the graph, I don't know anything about the production of food. So I'm going to eliminate that and go with C. Number 10 is another geometry problem, this time with a circle. So here we're calculating the area of the circle, And it says that the first time it's calculated, we get an answer of 307.72 centimeters squared. Okay, we know it's wrong because the correct answer should be about, and then we're given some options to choose from. So I know that the area of the circle is pi times r squared. Okay, if I were to estimate this, it looks like they're using 3 for pi, and the radius of the circle is about 50. So I gotta remember that r squared is r times r. So I would take 3 times 50 times 50, which is option A, 7,500, much bigger than the prediction. All right, next up we have some more geometry. We have a parallelogram here. It says quadrilateral ABCD is a parallelogram, and we want to know what is the measure of angle ECF. So here's the angle that we're looking for, ECF. That's outside of that parallelogram. Okay, well, first I need to know some properties of parallelograms. First, opposite angles are going to be congruent, so angle B would also be 70 degrees. Another property is that consecutive angles are supplementary, meaning that any two angles next to each other are going to add up to 180 degrees. So that means angle D and angle C, that interior angle of the parallelogram, should total 180 degrees. So 70 degrees plus that angle C should equal 180 degrees. If I treat it like an equation, I can subtract 70 degrees from both sides, and I find that angle C is 110. Okay, vertical angles, angles that are across from each other, are going to be congruent, the same measurement, so that means the angle that we're looking for is also 110 degrees, which is option B. Last one for this video, it says below is a drawing of a farm plot, and we have a scale that 1 inch is 0.75 miles. We want to know what is the perimeter of the farm plot. Well, first I'm going to find the perimeter of this scale. So 1.5 for both of these vertical sides across from each other in a rectangle. Those sides should be congruent. And then the horizontal sides, the top and the bottom, are each 2 inches. So the perimeter would be the total of those 4 sides. So I'm going to take 1.5 plus 2 plus 1.5 plus 2. It's going to give me 3.5 plus 3.5. That's going to give me a total of 7 inches. Now I'm going to think about this scale like a proportion. 1 inch is equivalent to 0.75 miles. And my perimeter is 7 inches, and I want to know what is the equivalent in miles. I'm going to do some cross multiplying with the help of a calculator and solve for x. So I get 7 times 0.75 is equal to 1 times x. So with a calculator, I'm going to type in 7 times 0.75, excuse me, which gives me 5.25 is equal to x. So 5.25, that's 5 1/4, which is option C.